measure variations is with the 5-number summary, which we had cruised through the other day. And the other way to measure variation is with what is called a standard deviation. And had talked about the fact that standard deviations are very, very popular. Very popular because regardless what set of numbers you're using, okay, if you're weighing guinea pigs, which is going to be in ounces, if you're weighing cows, which is going to be in thousands of pounds, if you're talking about incomes, which could be anywhere from 0 to billions, regardless how small or how big the numbers are, how spread out or how narrow they are, it always fits on that curve if the data is in a normal distribution. That makes standard deviations really nice. Okay? Does that make sense why the big push for standard deviations? Regardless what the data is, what the numbers are, whatever, if you've got a normal distribution, it'll always fit on that. One standard deviation in each direction will always account for what percent of everything that was looked at? Let's see, it was 68%. What was the next percentage? 95%. 99.7%. Okay, so regardless what the numbers are that are being measured, if it is a normal distribution, when you do standard deviations, it will always be those 3 numbers. Always. Which is really cool the way it works out. Does that make sense on why the big push for standard deviations and why I'm yet here another day bragging on standard deviations? Because they'll work for everything. They're great. Okay. So be sure for the test that you can compute standard deviations. And remember, it's just a series of steps. Be sure for the test that you can do those 5-number summaries. And with the 5-number summary, we didn't get a curve like this, but what did we create that was going to picture the 5-number summary? Remember the box and whisker plot? Be careful that you know how to do those. There's one on there, I promise. Okay. All right. Rule of thumb. Now, first off, let's talk about what does rule of thumb mean? Kind of a general guideline. On average, gas is about $2.50 a gallon for regular. On average, a little higher. It was about $2.60 coming in this morning. Okay, but does that mean that everywhere you go it's going to be $2.59.9? No, it could be higher, it could be lower, but on average it's going to be something around there. That's what rule of thumb means. On average, something around there. One way to estimate, okay, this is an estimate. This is not the exact computation. And there is a difference between an estimate and the exact price. In fact, if you take your car to the mechanic, what do you ask them before you leave it with them? I hope you know to ask this. About how much is this going to cost? And it's gotten to the point now, legally, where they have to give you a written estimate. And on that estimate, it says the estimate can't be off by more than 20%. So if they give you an estimate of $100, when you come back, it should not be more than 120 bucks. Why? Well, back in the good old days, oh, that'll probably be 15, 20 bucks to get it fixed. You come back and it's $800. What happened to the 15 or $20, dude? Okay? Yeah. So that's why that law got thrown in there that on estimates you've got to put within 20%. And if the mechanic's really above the estimate, they'll give you a call first and get your approval, get a verbal approval from you. Okay? So if you've got a mechanic that's just always overrunning their estimates and stuff, it's time to find somebody else if they're not calling and saying, hey, we found a tear in the CV joint boot, and we have to replace that boot as well, and that's going to be another whatever it's going to be. Okay. All right. So how do you estimate a standard deviation? Well, the way you do that, in general, man, Chuck, you're throwing in all kinds of protect yourself words. That's right. That's what an estimate's about. In general, you take the range and you divide it by 4. So if you just need to kind of guesstimate quick like, you're in a business meeting, and you don't have time to sit there and recompute standard deviations with 400,000 sales data points. What you can do is you can look at the range. Now, let's see the range. The range, isn't that next to the refrigerator? Wrong range, huh? The range is the distance from the low to the small, or the small number to the big number, right? Take that, divide it by 4, and that'll give you an estimate on the standard deviation. Okay. Where that divide by 4 comes from, okay, is we're breaking this up into 1, 2, 3, 4 sections. And that accounts for 95% of what's going on that way. Okay. So that 4 comes from breaking up your normal curve into 4 pieces. Okay. Now, what are you assuming with this? That there are no really high or low numbers, that things are behaving in a normal distribution. Okay. A car has a mean of 45 miles per gallon with a standard deviation of 4 miles per gallon. Estimate the minimum and maximum mileage you can expect under normal driving conditions. Ever been to a dealership and they got that sticker on the back window, and in big numbers up toward the top of it is the EPA estimated mileage? Does that guarantee that that's what you're going to get? No. Depends on how you drive. Okay? My daughter is very light on the accelerator. My son, on the other hand, he really wants to find out how fast that car can go. But he knows that he's not allowed to take it above the speed limit. We've made it very clear to him, if he ever gets a speeding ticket, he owns it. The car he doesn't own. And if he ever gets another car, he's paying for his own insurance. Okay? Whoa. Yep, welcome to the real world. Okay, so you're looking at this car. You've done a little research on it, which is a smart thing to do because some cars are more reliable than others. Some have issues. Every car has issues. For some cars, the issue is the radio. For other cars, the issue is the transmission. Which of the two cars would you rather buy? A car where the transmission breaks or a car where the radio breaks? Yeah, I'd go with the radio. Some people say, oh, the transmission. As long as the radio's running, I can listen while. Okay? Yeah. So you check them out, and you find that on some of the online information, it tells you it's a standard deviation about 4 miles per gallon. Do they really do this kind of stuff? Yes, they really do. This is what the real world does. Okay? And you're trying to get an idea of, okay, so what's the worst that this car can give me mileage-wise? Hi, Ben. What's the, unless I really go crazy on this thing and I've got my foot in the accelerator out through the engine, okay, what's the worst that this car is going to give me? Well, if you think about what's going on here, you have your normal curve. Now, it says 45 is the mean. Where would the 45 be on that curve? Toward one end or the other, or where's it going to be? Okay. Yeah, on this curve, it's going to be right here. So right here would be the 45. Okay. If you're assuming, I probably drive like 95% of the drivers. 95%, okay. 95% is how many standard deviations? 2. Okay, yeah, remember it goes 68, 95, 99.7. 68 is 1, 95 is 2, 99.7 is 3. Geez, we got to know this stuff? Yeah. Okay, so we're going to go out 2 standard deviations in each direction. Now, if you go 2 standard deviations to the left, that's going to be 41. And then you go another one, 37. Whoa. Well, I wasn't expecting that. It all just disappeared. Anyway, you got to see it before it just magically disappeared on us. The low end, about 37 miles to the gallon. Oh, there we go. Does that make sense? So if you buy this car, you can anticipate at the worst, unless you're sitting in a traffic jam for 3 hours with the engine running, at the worst, you're going to get about 37 miles to the gallon. Now, if you're like Cheap Chuck, who looks down the road and when traffic starts slowing down, yeah, some people keep their foot on the accelerator. Chuck kind of eases off. Saves brakes, saves gas. Why go and then hit the brakes? Like you're going to get there any faster so you can wait longer? Okay? So some people drive more like that, and they're going to wind up getting better or worse fuel economy. They're going to get more. Okay? So that means they're going to be headed this other direction, 49, 53. What these two numbers tell us is that 95% of all the people who drive these cars get somewhere between 37 and 53 miles to the gallon. That's pretty widespread, isn't it? With right around 45 being in the middle. Does that make sense how to use these standard deviation things? Okay, so right around 37 to 53. That takes care of that one. And that's got 5 or 6B done for us. Okay, so where does that take us? We've talked about the idea of measuring variations. We've talked about doing that either with a 5-number summary or with the mean and standard deviations. What we need to take a look at is if you have a large set of data and things are behaving in a normal fashion. Now, what does normal mean? Okay, so I come in with gray pants and a blue and white striped shirt. Is anybody going to leave the room and say, whoa, you should see what Chuck's wearing today? Can't believe that. Okay? Yeah, Trent's going to go out, geez, can you believe that? Look at him. He's actually got a long sleeve shirt on. Who'd believe that? Okay? I think I have 3 long sleeve shirts. One of them's on today. Normal means what you would expect, doesn't it? A normal distribution is talking about what we were just drawing pictures of. This bell curve. That deal. That is a normal distribution. Whole bunches in the middle. Okay, and fewer as you get out on the ends. Whether that be grades, heights. When you see somebody at 6'8", do you turn around, whoa? Why? You don't get to see that every day, do you? Okay, it's something a little unusual. This morning on the way in, at one of the intersections, apparently 2 cars tried to occupy the same space at the same time. And there was glass and plastic and antifreeze and all kinds of stuff all over the place and banged up cars. And as everybody everybody goes by, why do they slow down? Why are they looking? Because when was the last time you saw a wreck? It's probably been a while. Hint, when you go past a wreck, watch the cars in front and back of you because they're not watching. And where's the best place to have a wreck? At a wreck. Because everybody else is paying attention to other stuff. Okay? So, normal distributions. Most of the stuff's going to be in the center area. If we're talking about light bulbs or headlights or whatever, how long do they last? Most of them are going to be in that center range. Some of them are going to stand out a little more. One of the things that's very important with a normal distribution is to look at how much spread or variation there is. On this chart to the left, there's more variation. To the right, it's more consistent. There are times where variation is fine. There are times where you don't want variation. You don't. For example, you go to Outback Steakhouse and you order a steak and you go once, yeah, Trey's on this one. Okay, the steak's this big one time. The next time you go back and you order the same dinner, the steak's this big. And the next time you go back and the steak's this big. Are you going to start questioning what on earth is going on back there in the kitchen? There are places where you do not like variation. You want it to be the same. True? So one of the things that's focused on in analyzing data is how much variation is there. So that you know when you go to Outback, we go maybe once a year. Okay? So my samples are not real great. We get once a year sampling. But best as I can recall, does the steak vary very much in size if you order the same meal each time? Pretty much the same size, isn't it? Every time you go, Yahoo, they got the peanuts. Every time you go, yep, they've got the dinner rolls. Are the dinner rolls getting any smaller? No. Same size as always. Next time you go, the little cups with the flavored butter, are they getting any smaller? Nope, same size. You want consistency. There are lots of things you want consistency in. If you're dating somebody, you want one day to be really nice and the next day bite your head off and the next day flip a coin and see what you get. Consistency's nice in lots of things. Weather. You want it 105 one day, negative 30 the next? Well, hey, on the average, the temperature's not bad out, you know. Yeah, but it's kind of a brutal way to get that average. Okay? So, consistency is important. There's a lot of statistics that focuses on variation so that you know how much variation is there, how much spread is there. Basically getting back at how consistent are things. Okay? Which is what we're going to look at with this. Okay? Normal distribution is symmetric. Same amount on each side. Bell-shaped. Most is in the middle. Just a little bit out on the outer ends. Okay? The peak, that high point, is kind of cool because ideally that is the mean, the median, and the mode, all three in one place. How much better does it get than that? No matter how you measure it, it's the same thing. Okay. So very important on a normal distribution that's symmetric. Why do we have to throw in symmetric? Mirror image on both sides so it looks the same. Okay. You have the same amount of variation in each direction. It's not skewed. When you have that, the mean, median, and mode are all right there at the peak. And the cool thing is, if you know what the mean is, do you have to compute the